Click the bell icon to get latest videos from Ekeeda.
Hello friends, so today we are here to learn about the eigenvalues and eigenvectors. In this particular chapter, we are going to focus on different types of matrices, that is advanced matrices, skew Hermitian, Hermitian, symmetric matrix and skew symmetric matrix. So after learning about what is matrix, what is determinant, let us focus on very basic and advanced as well as advanced types of matrices. Let's focus upon symmetric matrix. What is symmetric matrix? As the name suggests, symmetric matrix is the one where if we go row as well as by column, we can get the same elements. Let's take an example and understand it. Suppose we have got matrix A. It is 3 by 3 matrix. As you can see in this matrix, we have got A, B, C as diagonal element. Also, we have got D, D. We can consider this diagonal as mirror, as A, B, C, as a mirror of this particular matrix. So the element on the left hand side and the element on the right hand side will be the same. As you can see, this diagonal element A, B, C is a diagonal which can act as a mirror. In this particular thing, the left hand element D and the right hand element D is same. Left hand element E and right hand element E is the same. Left hand element F and the left hand element is same. So in general, we can say element Aij is equal to element Aji. If we take 1 by 1 matrix, any element is a symmetric matrix. Consider second example, C. Let's take 2 by 2 matrix. In any symmetric matrix, diagonal element can be anything, but if we write 1 and 2, always remember diagonal elements are nothing but the mirror of the symmetric matrix. So if we are going to place and the other elements of the particular matrix, those elements should be same. Example, we can take this as 8 and 8. So in these matrices, if you see row wise and column wise, you will get the same elements. Let's check the first example what we had taken. First row is ADE, first column ADE. Second row is DBF, second column is also DBF. Third row is EFC and third column is also EFC. In 1 by 1 matrix, one element is same, one row, one column. In 2 by 2 matrix, it is 1 8 is the first row, 1 8 is the first column. If you take second row 8 2 and second column 8 2, both are same. So in general, we can say Aij is equal to Aji. So just like we saw what is symmetric matrix, let us focus upon what is skew symmetric matrix. So the word skew itself is a negative word. So when we say intersecting lines or parallel lines, the two lines could be intersecting or they could be parallel to each other. But there are few lines which are neither intersecting and nor parallel lines. So these lines are called skew lines. So just like that. So we have got skew symmetric matrix. As I said, skew symmetric matrix is nothing but the exactly a negation of symmetric matrix. As in symmetric matrix, we can say Aij, any element Aij is equal to Aji, such that in skew symmetric matrix we have got as learned before, skew symmetric matrix is nothing but the negation and the opposite of the symmetric matrix. In symmetric matrix, we have got any element Aij is equal to any element Aji is nothing but the same. But in skew symmetric matrix, as I said, it is the negation of the same. Aij is equal to minus Aji. So friends, it is very important to know what is the concept of symmetric matrix, skew symmetric, or you take Hermitian matrix or skew Hermitian matrix. But it is important how to construct any matrix. So in order to construct any matrix, we should know what is the nature of the diagonal elements we have got in that particular matrix. So let us focus on those elements. In any matrix, if you take diagonal elements, they are going to be A11, A22, A33, A44, and so on. So let us focus on 3 by 3 matrix and we'll construct a skew Hermitian matrix. So let us focus on 3 by 3 matrix and we'll now construct skew symmetric matrix. So if we talk about the diagonal elements, so they are gonna be AII. So let us focus for diagonal elements. AII, it is going to be minus AII. So if I add this on right hand side, therefore 2AII is going to be 0. Therefore AII is going to be 0. This means AII is equal to 0 throughout for skew symmetric matrix. That means element A11, element A22 and element A33, they are going to be 0. So friends, do remember this thing. In any skew symmetric matrix, we have got all the diagonal elements as 0. So let us focus on the same. So let us start this understanding this by taking one by one matrix. As I said, all the elements in skew symmetric matrix are going to be 0. So let us start with 1 by 1, and which is going to be absolutely 0. Let us focus on 2 by 2 matrix. As I said, diagonal elements are 0. As I said, in symmetric or skew symmetric matrix, this diagonal element or this diagonal acts as a mirror. So if I have this element as 5, this has to be minus 5 because it is skew symmetric matrix. So let us focus on 3 by 3 matrix. All the diagonal elements are 0, so we can take any element. Let's take here 1. So the corresponding element has to be minus 1. If I take 7 here, the corresponding element has to be minus 7. If it is A here, it is going to be minus A over here. So this is how we construct skew symmetric matrix. So let us learn about Hermitian and skew Hermitian matrix. As we learned about the symmetric and skew symmetric matrix, so let us focus on what is Hermitian matrix. A matrix is said to be an Hermitian matrix when element Aij is the conjugate element of the Aj. So friends, as I said, it is very important to know what are the diagonal elements in order to construct any particular matrix. So let us focus on how to construct Hermitian matrix. As I said, Aij is equal to this sign. As you know, this indicates the conjugate, that is the Aj, conjugate of Aj. Suppose in complex number, if we have got z is equal to x plus iy, therefore how do we write z bar, the conjugate of the same? X minus iy. Here we change the sign of I, and that is how we get the conjugate. If I want to get the conjugate of z bar, that is nothing but x minus I bar, the conjugate, that is nothing but changing the sign of this particular I, which is going to be x plus iy. So in order to study what are the diagonal elements of a Hermitian matrix, so let us focus on the diagonal elements, that is A11, A22, A33, that is AII. So for diagonal elements, it is AII is equal to conjugate of AII. Basically any number and its conjugate should be same. That means x plus iy has to be equal to x plus iy conjugate. Now we know what is the conjugate of x plus iy. That is nothing but x minus iy. So if we cancel this x and x from here, we'll get iy is equal to minus iy, which is nothing but 2iy is equal to 0. Therefore, we get y is equal to 0. If we see y is equal to 0, that is imaginary part is not present in any of the diagonal element. That means all diagonal elements are real in Hermitian matrix. So this is the learning and this is the point to remember. In any Hermitian matrix, all the diagonal elements are real. So let us construct Hermitian matrix. Let us start with 1 by 1 Hermitian matrix. In 1 by 1 Hermitian matrix, diagonal element, first row element, first column element is going to be the same. So it has to be real. So let us start with 2. This is Hermitian matrix. Now focus on 2 by 2 matrix. In order to construct any matrix, first we construct diagonal elements, and those diagonal elements should be real in Hermitian matrix. So let us take 2 by 2 real numbers. 3, 5. Suppose if I have got minus 2i over here, the conjugate of the same should be the corresponding element. The conjugate of the minus 2i is minus 2i conjugate, which is nothing but changing the sign of this I, which is going to be 2i. And this is how we construct 2 by 2 Hermitian matrix. Let us focus on 3 by 3. All the diagonal elements should be either 0 or real number. Suppose if we have got 5 plus 3i as the second element, so the corresponding element should be 5 minus 3i. Here if we have got 7, the conjugate of the 7 is 7 itself. If we have got a plus bi, then we should have a minus bi. And this is how we construct 1 by 1, 2 by 2 and 3 by 3 Hermitian matrix. So let us check in 3 by 3 Hermitian matrix row wise and column wise whether we have constructed the Hermitian matrix correct or not. So in 3 by 3, if we consider first row 0, 5 plus 3i and 7, and if we take the column 0, 5 minus 3i and 7. So let us write row wise. Row 1, 0, 5 plus 3i and 7, and let us write down column wise 0, 5 minus 3i and 7. Can't you see this 0 and 0, they are the conjugate of each other? This 5 plus 3i, 5 minus 3i, conjugate of each other, and this 7 and this 7, they are conjugate of each other. If you take the second row 5 plus 3i, 2 and a minus bi, and if you focus on second column which is 5 plus 3i, which is the nothing but the conjugate of the same, 2 is the real element. If you consider the second row which is 5 minus 3i, 2 and a minus bi, let us take the conjugate of the same. 5 plus 3i, which is the first element in the second column, 2 real number, and a plus bi, which is the exactly conjugate of the corresponding element. So this is how 3 by 3 Hermitian matrix is constructed. So let us focus on what is skew Hermitian matrix. As we know, in Hermitian matrix we have got aij, element aij is equal to conjugate of element aji. So that was the Hermitian matrix. But in case of skew Hermitian matrix, we put the minus sign. That is, element aij is equal to minus of the conjugate element aji. So let us now focus on how to construct a skew Hermitian matrix. As I said, all the diagonal elements are given the priority while constructing any matrix. So let us focus on the same. For diagonal elements, I is equal to j, so aii is equal to minus of conjugate of aii. So let us take aii as x plus iy. Suppose element aii is equal to x plus iy. So this has to be minus of x plus iy conjugate. So let us calculate first what is the conjugate of x plus iy. This is x minus iy. It is nothing but the changing the sign of I, which is x minus iy. So I'll take minus sign inside, minus x plus this minus minus becomes plus. So this is plus iy. Therefore, we have got x plus iy is nothing but minus x plus iy. Now this iy and this iy we can cancel, and therefore we can get x is equal to minus x. Therefore 2x is equal to 0. Therefore x is equal to 0. This means x is a real part. Real part is equal to 0. And once we have real part is equal to 0, any complex number turns out to be imaginary number with real part 0 and only imaginary part present in it. So let us focus. Therefore, in skew Hermitian matrix, all diagonal elements are imaginary. And this is what the learning of skew Hermitian matrix is all about. So let us construct 1 by 1, 2 by 2 and 3 by 3 skew Hermitian matrix. So while constructing 1 by 1 or 2 by 2 or 3 by 3 skew Hermitian matrix, we should know what is the property of diagonal elements. All the diagonal elements in skew Hermitian matrix, they are imaginary. So if we have got 1 by 1 matrix, so one element has to be imaginary. So let's take phi I. Now this phi I is imaginary number. So constructing B is nothing but 3i minus 6i. And other elements have to be real but negative of each other, which is if we have phi over here, I should have minus phi over here. While constructing 3 by 3, all the diagonal elements have to be imaginary. So if we have got 0, we can have 0 because this is also imaginary, 0i, 0 plus 0i. And also we have got 4i minus 10i. This is how diagonal elements will look like. Now let us focus on any other element. So if we have got 6 over here, I should have minus 6 as my corresponding element. If I have got 8 over here, I should have minus 8 over here. And if I have got 16 over here, I should have minus 16 over here. And this is how we construct 3 by 3 skew Hermitian matrix. So let us focus on 1 by 1. This property aij is equal to minus of aji conjugate. Does this matrix represent or follow the same property? Let us check out. Let us take row 1, which is going to be 0, 6 and minus 8, and column 1 as 0, minus 6 and minus 8. These elements are nothing but aij is equal to aji, 0, 0, 6, 6, 8, 8, but it is also following the minus sign. Minus 0 is 0, 6, minus 6, minus 8, 8, and also following the conjugate, all the real numbers, and the conjugate is going to be the same. So this is how we construct skew Hermitian matrix. We can have also imaginary numbers here. for this corresponding matrix. But all the diagonal elements have to be compulsory imaginary or complex numbers. So this was all about Hermitian matrix. Thanks for watching this video. Stay tuned with Ekeeda and do subscribe to Ekeeda.